So what exactly is programming? Well, you may have heard a phrase like this before. A computer program is a set of instructions. Well, here's the problem. This sounds like one of those phrases that might be technically true. It's kind of useless, like the human brain is 80% water. Because you hear this phrase, but then you see a complex program like Photoshop or Flash, or something playing high-definition video, or a 3D game, and you think, yeah, but that can't just be a set of instructions. But that's exactly what these are, all of them. Every computer program is a series of instructions, a sequence of separate small commands, one after the other. Now, there may be 5 instructions contained in a program, maybe 5,000, maybe 5 million. Each instruction is telling the computer to do something very small, but very specific. And the art of programming is to take a larger idea and break it apart into these individual steps. And the wonderful thing is, everyone can already do this. Let's imagine that you're sitting in your house in the suburbs waiting for a visit from a friend. Your phone rings. It's her, and she's asking for directions. She tells you she's at a nearby gas station. And you know it. You pass it every day. It's on your way home. So that journey, point A to point B, drops into your head as one piece. But you instantly know you can't communicate the journey the way you understand it. You have to break it down into simpler parts, and you have to think about it to break it down because it's so natural to you. So you start to pull this apart, and you say, you're going to need to turn right. Then drive 1 mile. Then you'll turn left on Acacia Avenue. Then you'll take the second right, and then it's the 4th house on the left. Specific, individual, simple, clear, self-contained instructions. Now you know that sequence here is vitally important. You mix these up, you'll get very different results. Turn right, drive 1 mile, take you to quite a different place from drive 1 mile, turn right. But this same level of simple instructions, turn right, turn left, go straight, could take you around the corner, or it could take you on a 5-year trip around the world, visiting every Starbucks along the way. You'd still have instructions like turn right and turn left. You just need a lot more of them. So with programming, we are giving directions to the computer. It's breaking apart a more complex idea, a more complex task, into its smallest individual instructions, and then using a programming language to write those instructions. Now, of course, if you've never programmed, it's not clear right now what those instructions might be. You know it's probably not turn right and turn left. So what are those basic fundamental instructions you give a computer? Well, they're often very basic. They are things like add 2 numbers together, or display a letter on the screen. Check to see if the user just hit the space bar. Change the color of 1 individual pixel. But as with driving directions, you string together enough computer instructions that will get you very far indeed. So when it might seem difficult to see how you get from basic examples you see when beginning programming to complex games or applications, well, that's what you get when you have 100 people writing these instructions for 60 hours a week for several years, combined with the ability of the computer to process them mind-bogglingly fast. Means that we could, if we wanted to, write a set of instructions that could calculate every single individual pixel on this screen 30 times a second. Now think about that level of speed, and think about why your instructions better be right. Because getting them wrong is like giving wrong directions to your friend when her car only has 2 speeds, 0 and 5,000 miles an hour. You get those directions wrong, and the next call you get is her asking why she followed your instructions to the letter, but her car is now in the middle of a forest crashed into a tree. Computers will do exactly what you tell them, so the instructions you give them better make sense. Now, in programming languages, we write these instructions by writing what are called statements. Statements in programming languages are kind of like sentences in English. They use words, numbers, and punctuation to express one thought, one individual piece. Most programming statements are pretty short, just a few words. Now, exactly what words, numbers, and punctuation you use depends on the programming language. Some languages want each of your statements to end with a semicolon, like ending a sentence in English with a period. And others don't. You just go to the next line and start writing the next statement. Some languages are all uppercase. Some languages are all lowercase. Some languages just don't care. Now, understanding the rules of each language is understanding the syntax of a programming language. So programming is the ability to take this idea in your head, break it apart into its individual pieces, and know how to write those pieces in the programming language you're using at the time. Writing your statements in the right order, using the right syntax. But what language? Well, sometimes you get to pick a language, and sometimes it's kind of picked for you. We'll talk about that in a moment.